All right, so we looked at multiplying polynomials by monomials today. So this actually takes what we were doing the last couple of days and puts it together. So the key is that there will be multiplication, which means we're going to have to use the product rule as we go. So let's take a step back and just look at the distributive property. The distributive property is technically a monomial, one term, multiplying a polynomial. So that 9 is going to multiply everything that's inside the parentheses. So the 9 multiplies the x squared, 9x squared, 9 times the negative 6, carry the x, 9 times the 2 gives us 18. We just multiplied a monomial times a polynomial. The thing that we're now incorporating is what happens if we multiply with variables. So the first method is just horizontal multiplication, just like the distributive property. I take the 2x, I multiply the 5x squared, I multiply the negative 3x, and I multiply the 12. So really it says 2x times 5x squared. We then have the negative 3x times the 2x plus the 12 times the 2x. So each individual term is going to get multiplied by that 2x. 2 times 5 gives us 10. And then the product rule comes back into play. X to the first times x to the second. Add the two powers together and we get x to the third. All right, negative 3 times the 2 gives us negative 6. 1x with 1x gives us 2x's. Then 12 times 2 gives us 24, and the x goes along for the ride. We make sure that it goes from biggest power of x to smallest power of x, and we're done. The second technique is called area of the box. So we take what we're multiplying, the 4x squared, and then we break our polynomial into the parts that it has. So this one has 3 parts. It's a trinomial, so 1 part, 2 parts, third part. And then we have to fill in the boxes based on what gets multiplied. No different than the last technique, just a little more visual. So the negative 4 multiplies the negative 6 and gives us 24. X squared, x to the third, x to the fifth. Negative 4 times the 7 is negative 28. X squared and x squared gives us x to the fourth. Negative 4 times 12 gives us negative 48. X squared goes along for the ride. The only thing we have to do is take it out of the box now. Write it from biggest power of x to smallest power of x. And we're done. So both techniques have merit. They both work just as well as the other one. I think the second technique is just a little more visual. Where this second method is going to come in a lot more handy is when we end up multiplying a trinomial times a trinomial. Keeping track of everything that we have to multiply is a lot easier in the box than it is writing out exactly what's going to get multiplied. So if we pick any method that we want to solve, either way, this 6x cubed is going to multiply all 3 of these terms. So I'm going to have 5x squared times the 6x cubed minus 2x times 6x cubed minus 4x to the fourth times 6x cubed. 5 times 6 is 30. X squared x to the third is x to the fifth. Then negative 2 and 6 is negative 12. 1 and 3 gives us x to the fourth. 4 times 6 is negative 24. X to the seventh. We're not done with this problem because it's not in the correct order. we move the 7x to the 7th to the front. We make sure all of the operations in front of our coefficients are relayed correctly. So it's a negative 24, so it's still a negative 24. It's a positive 30, so it's still a positive 30. And that's multiplying monomials times polynomials. We're going to make it a little bit more adventurous by adding in a second letter. So if I multiply these two terms, I'll use the box for this one. And then because I have more space, I'm going to put the 3xy over here. All right? When we're multiplying, it's basically multiplying the similar terms. So this 3 multiplies the 2 and this 2. So I get a 6 in both of them. Then the x has nothing to multiply in this problem. So he just drops into the final answer. In this box over here, the x multiplies the x and gives us x squared. I know it's getting kind of busy. I'm going to use blue. Same thing happens with the y. Y is going to multiply the y for y squared. And we get to this one, he doesn't have anyone to multiply. So he just falls into the final answer. When it comes to organizing, we first look at alphabetical order and by power. So X is the first letter in the alphabet. So we organize it by the X powers, like so. This next one we're going to talk about what happens if our powers have ties. Not this one, this one. So again, the 5AB is going to multiply all this. We'll go horizontal technique on this one. 5 times 4 is 20. A times a squared is a to the third. B times b is b squared. Then for the middle term, 5 times 2 is 10. A times a is a squared. B times b is b squared. Then 5 times negative 4 is negative 20. A times a is a squared. B times nothing, so it's just b. Now when it comes to organization, we still go by the powers of a, but since these two tie, we defer to our second power, so b squared is larger, it goes first, like so. If you're wondering, well, Ms. Carla, what happens if they're both this, a squared, b squared? Do we look at the third number in organization? Funny enough, if they both have a squared, b squared, these two terms can be combined into a single term and we won't have to worry about organization. So if they both happen to be a squared, b squared, our final answer would become, oh, not a plus, this, and you wouldn't have to worry about which term goes first because they'd actually combine into one term. So when it comes to organizing, alphabetical order, and then by biggest power. So A beats out B, cubed beats out squared, and if there needs to be any tiebreaker, you look at any additional letters. And that's multiplying monomials by polynomials.